All right, it's recording.
All right. Okay. Hi. We're group 16. I'm Nick.
I'm Maya.
And I'm Melvin.
And we're showing the demo for Lab 6. So Maya
Yes.
will start us off. Okay.
Yeah. I'll start off by showing the bubble sort simulation on the Windows XP. Hello.
ISE 10.1.
Yeah, there we go. Okay. First, this is the test bench that we use for the bubble sort. We just instantiate it, do the clock generation, a bunch of debugging outputs, and then we load instruction memory, load data memory, start the CPU, and then we read back the sorted data. It's already been ran so that it doesn't take as long as it needs to. But this is the data input that we're reading in this order, and then we will see it be sorted at the end. So in the beginning, first we're loading instruction memory, which is all this stuff over here. I'm zoomed in very close. So I'm just going to skim past all of that. And then we load the 9 data elements in here in data memory. And then, yeah, you can see at the bottom just all the instructions happening, a bunch of stuff. And then a time period where nothing happens. And then back here, we finally can start reading the sorted input, starting with FF. This is negative, yes, negative 56. This is actually supposed to be C9, but negative 56, negative 55, 0, 2, 10, 41 is 65, 62 is 98, and 7B is 123, and then the final one, which is 7D, is 125, which you can see right here. And yeah, that's it. You can also see in the console that it correctly prints out the last address, address 9 for 125.
All right. Now I'll demonstrate us showing it functioning on the FPGA. So we have our program instruction load regs, and I will just show you what the commands are just to demonstrate. This is what we have at our disposal. So if I type it again, load, and then we're going to first let's say load the program, or let's load the data, and then bubble sort data that text. Okay, cool. We have 10 randomly put organized data in there. Now we can load the instructions. All right, we have like 56 instructions apparently. And now I will show the demonstration of when we read it back, when we read our memory back, we should see all of our data organized. And yeah, it looks like it worked correctly. We have an ascending value from 56 all the way to 198, and it's stored in our memory address. We just decided to pick for the single thread 0 all the way to 10. And now I'll just hand it off to Nick for the multi-thread demonstration.
All right. So yeah, this is the demonstration for the multi-threading. So as you saw, Melvin established the second logic, so we can use that network connection. So I'm going to use our Perl script to load data via network. So yeah, let me go do that first. Oh, it doesn't pop up. Oh, multiple thread programs. Sorry about that. Okay, so as required, there's a total of 4 threads. So you can see here that 4 threads were given different data and are also use different parts of the register file. So after execution, we can just look at representative slices just to show like how the sorting went. So I think the call for this one was just read. So yeah, similarly with what Melvin showed, you can see that different values are stored in different locations. All right, well, that concludes the demo.
Yeah, and the C program can be viewed in our GitHub as seen in our lab report. And that is all.